Hello, greetings, and welcome. I'm Brian Posey, and today I want to show you some problems that can occur as a result of the way that the system path is configured. And I also want to show you how to use PowerShell to detect and help resolve some of those problems. So as you can see, right now I've got the Windows System Property Sheet on screen, and I'm going to go ahead and click Environment Variables, and then I'm going to select Path in the System Variables section and click Edit. So this is my path. So what you see right here is a fairly standard path. We have a few entries that were created by Windows, such as System Root System32 and System Root, and then a few others. We also have a path that was created by a third-party application, C:"Program Files, NVIDIA Corporation, NVIDIA NV DLISR. This particular machine doesn't have a lot installed on it, but if a machine is application heavy, then this path can become quite long. And this actually brings up the very first problem that can occur, a path that's too long. Your total path size, and when I say total path size, what I mean is everything that's on the screen combined, the total path size can't exceed 2048 characters. So if you have a bunch of third-party applications that are all adding to the path, that path can very quickly grow in size, and in extreme cases it can exceed the total maximum path size that is set by Windows. So that's one problem that you could potentially run into. Another problem that you could end up running into is that you may have a path that points to folders that no longer exist. Let me show you what I mean. I'm going to go ahead and click New, and I'm going to enter C:/temp1. So temp1 is now part of the path, and if I go to File Explorer, you can see that I've got a temp1 folder, and if I were to erase that, temp1 is now gone, but the path still exists. And I could even click OK to close that out and click Edit again. And you can see that we still have a reference to temp1, even though the folder no longer exists. So if you end up having an excessively long path, then one of the ways that you may be able to pare that down is by looking for references to folders that no longer exist. So I'm going to go ahead and add temp1 back in because we are going to use that a little bit later on in this video. And that brings me to another problem that you could potentially run into, and that is duplicate path entries. So, for example, if I were to click New, and I were to type C:/temp1, there's nothing stopping me from adding another instance of temp1 even though it's already in the path. So we now have two duplicate entries. Now that in and of itself isn't necessarily a problem, but it does mean that you're taking up unnecessary space within the system path. So in order to show you another problem that can exist, I need to add one more location to the path. So I'm going to click New, and I'm going to add C:/temp2. And I'll go ahead and click OK. And so our path now includes a couple of references to temp1 and then temp2. So let me go ahead and close this out. And I want to show you why what I just did matters. So now I'm going to show you one of the more serious and yet more common problems that can occur with regard to the system path. So if you take a look at this screen, you can see that I've got File Explorer open, and I'm looking in the temp folder, and I've copied a couple of Windows utilities to this folder. The first one is calc.exe, and if I double click on this, it opens up the Windows calculator. The other one is write.exe. And this is a leftover from way back when, but it's a lightweight word processor that's a part of Windows. So we have two executables that both function as standalone programs, and I've just copied them from the C:"Windows System32 folder over to my temp folder. So what I want to do now is I want to copy one of these to my temp1 folder and the other to my temp2 folder. As you'll recall, both of those are in the path. Then once I've copied these, what I'm going to do is rename them, and I'm going to give them both identical names. So I'll start with write.exe. I'll right click on that and then choose copy, and I'll go to C and temp1. I'll right click and choose paste, and then I'll right click again and choose rename, and I'm just going to call this myprogram.exe. Next I'll go back to the root folder and then go into temp, and I'll do the same thing with calc. And this time I'll go to temp2, and I'll also call this myprogram.exe. So the problem is that we have two locations that are both in the path, and they both contain identically named executables, but the executables do two different things. The executables are not identical. So which one is going to execute? Well, let's find out. So I'll go out to the terminal, and let's open a command prompt window, and I'll go to my root directory, and let's just type my program. and I'll press enter, and it looks like write executes. So how come write executed as opposed to the calculator? Well, let's take a look. So here we are in the system property sheet. I'll click on environment variables, and then I'll select my path and click edit. And you can see that temp1 appears before temp2 in the list. So if I were to open up File Explorer and go to temp1 and double click on my program, that opens up write. So because the path found temp1 before it found temp2, it ran the copy of the program that was located in temp1. So if we wanted to run the program that was in temp2, we would have had to have gone directly to it. For example, I could say cd temp2 my program, and this time the calculator opens. So how do you fix a problem like that? Well, the only real way to fix it is by modifying the path. But I've created a PowerShell script that can help with some of that. So this script is designed to check for various common problems related to the system path. So if I scroll down to the bottom, here we have the demo flow. So the very first thing that we test for is the path structure. And so the only thing that this does is it lists the various elements that are a part of the system path. From there, the script looks for duplicates. So as you'll recall, we've got two instances of temp1 that are a part of the system path. So that's a duplicate, and the script should be able to find that. Next, we have command resolution. So in other words, we're looking for one specific command, and we check to see where we find it. So because we've got a command called myprogram, or myprogram.exe actually, stored in two different places, the script should be able to help us find that. And then finally, the last thing that I'm doing is backing up the system path. Because if we're looking for problems and we find problems, we're presumably going to make some changes to the path. So it would be a good idea to have a backup copy just in case anything goes wrong. So let me go ahead and run the script. And then once you see how it works, I'll go ahead and step through the code. Now, before I run the script, there's something really important that I need to point out. And that is that when you open PowerShell, PowerShell reads the environment variables once. So if you look at the environment variables in PowerShell and you get something unexpected, then the way that you would fix that is just by closing out any open PowerShell window and then reopen PowerShell, and everything should be fixed. And if you're not sure if PowerShell is going to be showing the correct environment variables or not, then all you have to do is type $env, and that's the environment variable, :path, and press enter, and you can see the system path. So here you can see C:temp1, C:temp1, those are the duplicate temp1 entries that I created, and C:temp2. So these are the entries that I added to the path just a few moments ago. Now, one thing really important that I want to go ahead and point out right now, and we'll come back to this a little bit later on, but you'll notice that each element of the path is separated by a semicolon. So we have a semicolon right there, we have another one here, and so on and so forth. So there's a semicolon between each individual element within the path, and that's going to be important when we start taking a look at our code. So I just wanted to go ahead and show you that. So with that said, let me go ahead and clear the screen, and let's run the script. So the first thing that the script does is it takes a look at the path structure. So here we're listing all of the individual elements within our path. So we have C:\Windows System 32, C:\Windows, C:\Windows System 32 WBEM, and so on and so forth. And then we get a little bit further down the list, and we have C:temp1, and then we have our duplicate C:temp1, and then C:temp2, and then we have the user path. So then we come down to the section that's meant to look for duplicates. So here we have duplicate entries being detected, and the duplicate entry is C:temp1, and it tells us count 2. In other words, there are 2 occurrences of C:temp1 listed within our path. So right away we know that there's a problem. Temp1 is in our path statement twice, and the information up here verifies that as well. Here we have 2 occurrences of temp1. So that's certainly something that we would want to fix. And as a matter of fact, let's go ahead and do that. And I'll go ahead and select one occurrence of C:temp1, and I'll click delete, and click OK, and I'll click OK again. And we're going to have to close out PowerShell and reopen it, otherwise the changes aren't going to be recognized. So I'm going to pause the video for 1 second while I do that. Okay, so I've closed and reopened PowerShell. Let me go ahead and go to my scripts folder, and I'll run the script. So this time, when we look at the path structure, we only see one instance of C:temp1. And if we look at the duplicate detection section, then here we see no duplicate entries found in the path. So we fixed a problem right away. Now, if we looked at the next section, we see command resolution. And right now we're searching for my program. As you'll recall, I had two separate executables that I referred to as my program. So what we're doing here is we're searching all of the different locations that are specified within the path to see if my program exists. So here we can see that my program was found in C:temp1 and again in C:temp2. And in both cases, it's named myprogram.exe. So we have a conflict going, and that's a problem that we would want to resolve. And the very last thing that I'm doing is I'm backing up the path. So you can see right here, path variable backed up to C:users Brian app data local temp path backup.txt. And let's go ahead and take a look at what that looks like. Okay, so I'm in File Explorer, and I'll go to C, and then users, Brian, app data, local, temp, and here's my path backup file. I'll go ahead and open that. And there you see the backup of the system path. And then let's take a look at the script. Okay, so here we have our script, and I'm not going to step through every single line of code because the script is a little bit long, but let's just take a look at how this works. I'll scroll down to the bottom because this is where the demo process begins. So the very first thing that we do is we check the path structure. So you can see that we have a write host command, and it displays the words path structure in yellow. And then we call a function called Show-PathVisualization. So if I scroll up, here's the Show-PathVisualization function. So what we're doing is we're creating a variable called pathDirs, and we're setting that equal to $env:path. And you'll recall that earlier I showed you a command that you could use to display the path in PowerShell. This was the command right here. But I'm appending -split and then apostrophe semicolon apostrophe. Now, when we took a look at that path earlier, as a matter of fact, let me go ahead and do that. I mentioned that every element within the path was separated by a semicolon, and you can see that right here. So what we're doing in this script is every time a semicolon is encountered, we're splitting the line, so that what we end up with is each individual element of the path stored in a separate location. So then I've got a write host statement that displays current path structure on the screen, and in case you're curious, this backward apostrophe in that you see right here and right here, that just indicates that we want to move to a new line. So then we have a for each loop that loops through all of the elements that we've extracted from the path, and then we're using a write host statement to display each one of those individual elements. So then, if we go down here, the next thing that we're doing is we're looking for duplicates. So we're displaying the words duplicate detection, and then we're calling a function called Get-DuplicatePathEntries. So I'll go ahead and scroll up, and here's the Get-DuplicatePathEntries function. So the first thing that we're doing is we're creating a variable called pathDirs, and once again we're setting that to our path, and we're splitting that at the semicolon. And then we've got a where object, and we're checking to make sure that we don't have any blank spaces or anything like that. So the next thing that we're doing is we're creating a variable called grouped. And what we're doing is we're looking at the path directories and we're grouping objects. So in other words, we're taking any duplicates that might exist and we're grouping those duplicates together. Then I'm creating a variable called $duplicates, and I'm setting that equal to $grouped, where the object count is greater than 1. So in other words, anywhere that a duplicate exists, then we're adding that to $duplicates. So then we have if duplicates, so in other words, if duplicates exist, then write host duplicate entries detected. And then for each group in our duplicates, what we're doing is we're using write host to display on the screen the duplicate count, and we're also displaying the group name and the group count. So in other words, we're taking a look at how many duplicates exist for each duplicate entry that's found. Now, if no duplicates exist, then we use this write host statement right here to simply say no duplicate entries found in the path. So then the next thing that we're doing is command resolution. So you can see that I'm calling a function called Get-ExecutableResolution, and I'm passing a command name as a parameter, and the command name that I'm passing is my program. Now, as you'll recall earlier in the video, I took a couple of standard Windows programs and I renamed them my program. So that's why this says my program, because that's what I'm looking for. you would replace this with the name of any program that you're particularly interested in finding. So if I scroll up, we come to the Get-ExecutableResolution function, and we have a parameters section where we're passing the name of the command that we're searching for. Then we're using rightHost to display that we're searching for whatever that command name is. And then once again, we're creating a variable called pathdirs, and we're setting that equal to all of the different entries within our list of paths. So then there's also a check in here for the sake of safety where we're looking for white space or null values. So the next thing that I'm doing is I'm creating a variable called candidate. And for that, I'm using join path. And to join the path, what I'm doing is I'm specifying the directory as the main path, and then the child path is going to be the command name. Then I've got candidate exe, and what I'm doing is I'm taking $candidate, which is the path and the command name, and I'm appending .exe. So what we end up with is the full path and file name. So what we've got here is we've got a few if and else statements that we're using to check to see if our file that we're looking for exists within the various locations within the path. And so we've got all of these lines of output that are controlled by rightHost, saying that either the command name was not found in a particular location or that it was found. So then the very last thing that we're doing is creating a backup. And to do that, I'm calling a function called Backup-PathVariable. And that function is right here. So as you can see, I have a parameter defined, and that parameter is a string called backup file, and I'm setting that equal to $env:"temp/pathbackup.txt. So env:"temp, that's essentially providing me with the path where this backup file is being stored. You could substitute a literal path if you wanted to. So the next thing that I'm doing is I'm taking $env:"path, that's our system path, and I'm piping that to out file. So that writes the contents of our system path out to a file, and then we have file path, and then we're using $backup file, and we're encoding this as UTF-8. And then we're displaying a message when all of that is done saying path variable backed up to, and then the path and file name of our backup file. So that's how that script works. And I'll go ahead and run this one more time for you. So you can see the different sections. First we look at the path structure, then we check for duplicates, then we perform the command resolution to find out if our target command exists in multiple locations within the path, and then finally we perform a backup. So that's just a really quick way that you can use PowerShell to search for some common problems that exist with regard to the system path. I'm Brian Posey. Thanks for watching.